Hello, welcome everyone. Today we will discuss a very small concept in physics. We usually define it in chemistry as well. So it's a common subject, common concept in physics and chemistry. It's called latent heat. So latent actually means hidden. So why do we say hidden? Because latent heat means the amount of heat that you usually, or the amount of energy, because heat is a form of energy required to convert a substance from one state to another. So actually, at that point, when you are changing the state of a substance by applying some form of energy, usually it's heat. So when you are giving some amount of energy to a substance, its state is changed. It gets it gets transformed from one state like solid to liquid. So the amount of that heat is called latent heat. So it's hidden. Why? Because when you are changing the state, when a change happens, the temperature doesn't change. So if you say there is an ice cube which is at a temperature minus 10 degree, and you are heating the same ice cube, and its temperature will increase till it is zero. Like temperature is increasing, you are applying the heat, but it is still in it is solid phase. So when the substance reaches, when the ice cube reaches to a 0 degrees celsius, the change begins. That is, it begins to melt. So now the ice cube will get converted into the water, but the same water, the same liquid will be at the same temperature. That is, ice at 0 degree has the same temperature when it gets converted into liquid. So transition occurs at a constant temperature. So that's why it's hidden, because you don't see the change in temperature. Even though you see the change in state, you don't see the change in temperature. So the measuring device, measuring concept is temperature, but because you do not see any change in, change in the uh, temperature during the phase transition, so you call it a latent heat. The energy you have supplied is there, but temperature has not changed. So latent heat has uh, two types. One is latent heat of fusion. So when a solid, that's ice, at 0 degrees Celsius or at some temperature gets converted into another phase, that is liquid phase, solid to liquid, is called latent heat of fusion. So for water it is around 3.33 into 10 raised power 5 joules per kg. And the second type is latent heat of vaporization. It is 22.6 into 10 raised power 5 joules per kg. Like it's the similar, but here the water, that is the liquid, gets converted into water vapors. And we have, there is a formula for the same, like latent heat of fusion, or latent heat simply is is given by the formula that's heat energy is equal to mass into latent heat. So when you are supplying the heat, it is directly proportional to some to the mass of the substance, and the constant of proportionality is L. That's latent heat of latent heat. It depends upon the phase, the state. Then you can call latent heat of vaporization or latent heat of fusion. So Here L comes to be like L comes to be Q by M here. So value depends, the latent heat depends on the pressure, and we have a very important concept here. Yes, and if you carefully look at the latent heat of vaporization of water and the latent heat of fusion, like you have to apply 3.33 into 10 power 5 joules per kg for every kg of ice. You have to apply 3.33 in 10 to 5. But if you do the same transition for from liquid to vapor phase, you will require multiple times than this. That's from liquid to vapor phase, like 22.6. So like water, when it comes from solid state, will be will be less destructive, will cause less burners than the vapor, because the vapor has higher amount of heat inside it, though it's at the same temperature at the as the liquid, but because you have more energy in it, so there are more possible burners. So like vapor or steam is usually more serious. That's is more dangerous, causes serious burns than the liquid at the same temperature. So you must have observed sometimes that when you are, when you are taking a hot tea, you can observe that the vapor is really hot. You must have, like we were from a Himalayan region, we have similar experiences as well. So this is latent heat, and you can clearly find the SI unit of, like it is joules per kg. And one more thing, there is a graph between temperature and heat, like you can see here, you know when it was in a solid state, like it is at a negative temperature, then you are heating it till it reaches the boiling, like melting point, that is 0 degree. Then it was a solid state, it reaches the 0 degree, it is still solid state, but here the transition begins. It gets converted into liquid phase at a constant temperature. That's the constant, because it is a horizontal line, though it doesn't seem to be, but it is a horizontal line that I'm trying to draw, because it is parallel to the heat axis. Then we have, like when it is now the water, you are still applying heat energy, and here the transition begins, that is liquid at some at the melting point. You are applying it, the temperature rises, then it reaches the boiling point, then again the state begins to change at a constant temperature, that is 100 degrees Celsius, and the water begins to boil. So it's totally clear, you can clearly see these things, and it is really easy to understand, hopefully. Hope you get it. Thank you.